Hi guys, in this video, in this section, we'll focus on R combination with repetition allowed. I assume that before you watch this video, you have watched the, the video posted in Canvas, section 9.6, R combination with repetition allowed idea explained video. You definitely want to watch that before you look at this one. Because I have explained how to treat this type of problem using some grocery shopping experience. Okay, so once you follow that video, let's do some more problems, and then we'll generalize the result into a theorem. Okay, so now let's take a look at Jacob wants to eat 10 fruit items with no limits on any. That means he can eat as many as he wants from each type. Here are the types that are available: apples, bananas, oranges, and peaches. So this time there were 4 different types of fruits. In my video there were 3, right? There were 3. So now how many possible ways Jacob can select the variety of the different combinations of the fruits for these 10 fruit items? So in this case, because we have those 4 different types, just imagine into the grocery store you have apples, bananas, oranges, and peaches. So how many dividers you will need? You'll need 3 dividers, right? So the dividers is really just 1 less than the types of items available. So therefore we need 3 dividers. And how many blanks to fill? Because we have 10 fruit items, so we need 10 blanks to fill for those 10 fruit items. And we also need 3 more blanks for those 3 dividers. So here we'll have 10 plus 3, which is 13. By the way, where's the 3 is from? Basically, it's from 4 minus 1, okay? We need to make sure that we are clear where each number is from. Now, how many ways can Jacob choose 10 fruits from these 4 different types, assuming there are unlimited supply? That means you are not going to, that means more than 10 apples for Jacob to choose. If he wants to eat 10 apples, that will have enough apples for him to choose. Now how many ways to do that? Because we have 13 blanks to fill. When we fill in the dividers, all the fruits are automatically determined. So therefore total number of ways for Jacob to get 10 fruit items will be 13 choose 3. Again, if you have not watched my previous video, you probably will get lost right here. So make sure that you watch my previous video before you even look at this one. So this is how we handle this one. Now let's generalize the idea. The theorem 9.6.1 says the number of R combination with repetition allowed can be selected from a set of n elements. So n is the number of categories, okay? Number of categories. Okay, so in this case, like n in this particular case will be 4 different types of fruits for Jacob to choose from. And this 10 is the R combination. Here this 10 is the R. Now how do we actually correctly count? We need to know how many dividers, because n is the number of categories, so the number of divider will be n minus 1. Now how many total blanks that we need to fill in? R will be the number of elements we need, right? And n minus 1 will be for the dividers. So basically if you add them all, basically it's R plus the n minus 1. Okay, n minus 1 is the number of dividers again. And R is the total, in this case, the total number of fruits item Jacob wants to have. So this is the general result. This equals the number of ways R objects can be selected from n categories with repetition allowed. Okay. Now let's continue to do different exercises. The more you do, the better you will be. Now suppose this time we say, let's increase say 15 fruits, okay? And there are 5 different types of fruits available: apple, banana, grapefruits, orange, pears, okay? How many dividers do we need? So there are 5 different types, so we need 4 dividers, right? And because there are 15 fruits, 4 dividers, total blanks to fill is 19 blanks to fill, which is 15 plus 4. And how many different possible ways for Jacob to buy these 15 fruits? It will be 19 choose 4. Just place the divider and automatically determine the number of ways. Now, continue. If Jacob buys at least 6 apples, now let's take a look at the variation now here. So he must buy 6 apples, and then how many different combinations are there now? So this question can be looked at in this way. So in other words, 6 is already determined, right? So that you don't need to worry about that. At least 6 apples are determined. We just need to determine, we only need to think about the rest of the 9. So need to consider the rest of the 9 fruits, the fruit items, right? So therefore in this case, this question, I hope that this doesn't bother you. You just treat this as a new question, like how many ways for Jacob to buy 9 fruits from these 5 fruit items. Don't worry about this anymore, right? So again, the number of dividers will be still 4 because there were still 5 categories. And number of blanks to fill will be 4 dividers plus 9 fruits to be determined, so which is 13. And how many possible combinations? 13 choose 4. Now again, you should continue to think about the next one. Pause the video if needed. Jacob plans to eat at least one of each fruit. So apple, banana, grapefruits, orange, and pear. So each one, at least one. Okay. Now, how many different combinations now? So the divider is still 4 because we know at least one of each. So therefore 5 fruit items are already determined, and we just need to worry about the rest of the 10, right? So therefore the number of blanks to fill will be 4 dividers plus the rest of the 10 fruits to fill, to determine. So total 15. So 15 choose 4. That would be the how many different combinations. What if Jacob wants to eat at least 2 apples, 1 banana, 1 orange? Okay. Then in this case, 4 dividers, 2, 1, 1, 4 fruit items are already determined, so we are left with 11s to choose. So 4 plus 11, which is, previously I'm not sure why I would do that. So this actually is 14, right? So sorry about that. 14 choose 4. Probably I was thinking about this problem when I was doing that. So this is 15, and therefore 15 choose 4. Okay. All right. So there are some other variations that will be available, can happen. For instance, what if the fruits are not unlimited supply? So what if there's only 1 apple available? So how about this? Let's do one example like this. Suppose there is only 1 apple, okay, only 1 apple available left in the store, so that available. Now, how can we correctly count how many possible ways? So I'll discuss this into different cases. So the case 1 will be, okay, again, you can pause the video and think about this. Case 1 is Jacob buys the apple, right? So Jacob buys the apple, buys that apple, and then decide the rest of the 14 fruits from the other 4 types. Okay, and then by and then the 14 fruits, total 15, right? 14 fruits from the four, the remaining 4 types, right? 4 types. In this case, 4 types, which is 3 dividers and 14 fruits. So therefore, we have 3 dividers plus 14 is 17, and you choose 3 dividers. This is how many ways to make up to choose 14 fruits from the rest of the 4 types when he buys the apple. And case 2 will be Jacob did not buy the apple, right? So no apple. Let's just call it no apple. That means 15 fruits from the 4 types. Okay, so which means 3 divider plus 15, which is 18. Choose 3 dividers, right? So therefore, in this case, it will be 17 choose 3 plus 18 choose 3. That's the total count. Well, I'm gonna stop this video now, and then I'll make another video to look at some other variations. So this technique is so powerful that you can solve actually a lot of different types of problems using the same technique.